Hello everyone and welcome to the channel. In this video, we're doing more EIGRP. Once again, if you look at the top of the document, you'll see a list of topics that I've already covered in a live study session. Since then, I've done separate videos for each of those topics, and we're now going to look at metric weights or the K values. Let me quickly introduce the topology. So I have R1, R2, and R4 running in this lab. We might not even need all of them for the purposes of this video. So if I quickly go back to Notepad, this shows what has been configured on those devices. Although there are some exceptions. For example, R3 is no longer configured as a static neighbor, so this one has been removed. And also I've tweaked the information here a little bit to include where this configuration has been applied. So R1 has been configured in classic mode and all the others in named mode with various configurations. Now let's actually jump to the configuration examples. So once again, we'll use Cisco documentation. And I have the EIGRP configuration guide open here. Similarly to the last video where we discussed passive interface, the metric weights are also under the EIGRP parameters. So here you can see the configuration for classic mode and over here for named mode. Now the command itself is simple, but there are a few things to discuss here. For that, let me go to the master command list over here. Now this is the command that we're going to use, and you can see right here that the syntax is slightly different for classic mode and named mode. Now the first thing to note about the K values, valid values are 0 to 255. Next, let's scroll down a little bit to the usage guidelines. So what does the metric weights or the K values even do? Well, the answer is right here on the first line. Use this command to alter the default behavior of EIGRP routing and metric computation and to allow the tuning of the EIGRP metric calculation for a particular type of service. So basically, changing the metric weights or the K values allows you to modify the EIGRP metric calculation. You can tune it to suit your needs. By default, only K1 and K3 are used. K1 affects bandwidth and K3 is linked to delay. So if you look at how the metric is calculated, the formula is displayed right here. So now you have K1 times bandwidth and K3 times delay. Only these two are taken into account by default. The other K values are set to 0 by default, so they basically cancel out the rest of the metric calculation. Over here. And actually this one shows the metric calculation formula in an interesting way, because it shows K5 and K4 over here. I did not pull up the entire formula for the EIGRP metric calculation. It would have been beneficial to take a look at that as well. Maybe let me pause the video for a second and let me try to find the full formula. Okay, so this is probably the best resource that I could find. This is from the CCIE Routing and Switching version 5.0 Official Cert Guide Volume 1. It's a great book, by the way. This is the formula for the classic metric computation, actually. I don't actually want to go into too much detail about the formula itself. So let's just kind of go over this quickly. And really what I wanted to show here is that how those K values affect the formula. So again, by default, K1 and K3 are set to 1, and the other K values are set to 0. So that means anything set to 0 is effectively not taken into account. So right away you can take out this section right here, this one. So what we're left with is the bandwidth with K1 and then the delay with K3. So this is how we can use the K values to tune the metric. So that's one way to influence the metric formula. Because those K values are 0, those sections of the formula are basically cut out. So the other way is to change the K values inside the valid range, which was from 0 to 255. By adjusting the K values, we can give more preference to certain K values. Maybe preference is not the right word to use here, but the point is that you can tune the metric formula by changing the K values. So if we consider only K1 and K3, we could change this between 0 and 255. Oh dear. And that's obviously going to affect the final metric value. Okay, let's go back to the command syntax. Oh, one very important thing to understand. It is crucial that all EIGRP routers in the autonomous system calculate the metric in the same way. So that's why those metric weight values must match between neighbors. If they don't, you get a K value mismatch and the EIGRP neighbor adjacency will go down or it will not form in the first place. We should see that happen when we start tweaking those values. Oh, actually, one other thing I wanted to point out here in the command syntax. So the first value here is TOS, or the type of service. So pay attention here when you insert the values. So this is not K1, it's TOS value. And also notice the syntax description here. It says type of service, this value must always be 0. Now, I don't think this is true. At least the command line should not give us any errors. We should be able to configure that with the 1 as well. Possibly even other values. I haven't tried. Actually, another thing I realized, note that the classic mode only supports K values from 1 to 5, and the name mode supports K values from 1 to 6. Okay, let's go back to the configuration examples. So now for R1, we'll do it in classic mode. So this one right here. So let's go on Notepad. So metric weights. And then once again, the first value is the TOS. The command syntax said this value must always be 0. I don't think so, so we're going to try something different. We'll set it to 1. And then we have the 5K values. So let's do something like 5, 4, 3, 2, 1. Okay, let's see what happens with that first. Go on R1. And then configuration mode. Then enter the EIGRP configuration. And let's paste this. Now, once I do this, the neighbor adjacencies are going to go down because, again, the metric weights must match, or the K values must match. So let's see that. Boom, right away. And we'll keep seeing this message here over and over again. I actually have a Wireshark packet capture running in the background, so we'll see if we notice the difference here. This is the peer termination. I don't want to see that message. Okay, so here we see that this packet is coming from R2, so that has still those default values configured. So K1 and K3 are set to 1 and the rest of them are set to 0. So let's try to see a hello packet that R1 is sending out. It just keeps sending these peer termination messages. Anything else? Why is it only sending out peer termination messages? Maybe because it's receiving those hello packets from the other side and then realizes that the K values don't match. So it rejects the EIGRP adjacency. Let's try something here. Let's try to include the source here. If we see any difference. No, only peer termination messages. Fun. Okay, let's take that part out. But anyway, here we still see the default K values. Okay, let's leave the packet capture for now. And this is just filled with messages. Actually, I'm going to shut down R2, or let's see if I can shut down the EIGRP process. So conf t router EIGRP, I think it's Venom. Do we have a shutdown command here? Yes, we do. Because I don't want to see those messages from R2. We'll fix it on R4. Okay, so if we go back to R1, we should see those messages coming from R4 only. Yes, so all these are R4 now. So R2 is gone. That's good. So let's just do a quick copy paste here to see the configuration. Okay, so this is interesting. Notice that this was changed to 0, the TOS value. If you look at this line here, and now it just keeps going and going. Oh dear. Let me just quickly copy this. Okay, I had to quickly pause the recording because things were getting out of control. So coming back to the TOS value. Remember the command syntax said that it must always be 0. So we inserted this command where we changed it to 1 and the command line accepted it. There was no error message, nothing. However, look at the running configuration. It has been changed to 0. So indeed that value has to be 0, but the command line does it automatically. That's interesting. Now let's fix things on R4. Let's look at the command syntax first. So for EIGRP named mode, this is the example that we want to focus on. So the metric weights are configured under the address family configuration. Maybe for fun, we'll try to do some random numbers for TOS and for K6. Let's see what happens. I actually want to know what happens if K6 doesn't match because classic mode does not use K6. So here, now I'm in the wrong place over here. So metric weights. And then we'll say 13. And what were the other numbers? 5, 4, 3, 2, 1. And for K6, let's do something like 47. That's pretty ridiculous, but let's see how it goes. So copy this, go on R4. Conf t router EIGRP HEDWIG for my Harry Potter team. Then address family, IPv4, unicast, auto, and 12. And then the metric weights. Okay, this one does not accept 13. Interesting. Let's see what values it does accept. Oh, 0 to 8. I should have known that. Let's say 8 then. And then copy the rest. Like that. So we still get the k-value mismatch. Let's actually look at the packet capture again, unless it's a complete mess again. So over here, I want to see the hello messages now. Okay, so this one is going from R1 now. This includes the k-values. And notice that R1 is actually carrying K6 as well, although it's not used in its metric calculation because R1 is running classic mode. So this is why they can still detect that k-value mismatch. So it's still carried in the packet. Let's see from R4. Now these are all the termination messages again. I cannot find one with R4's parameters, but it should have 47 for K6. Let me do this. Let me stop this and close this. And we'll try from R4 side. This was supposed to be a quick video, but it's taking a lot of time. So EIGRP, let's see what we're sending out now. There we go. Now we can see the K6 configured as 47. Okay, let's change the command on R4 since we're still over here. So we'll change this to 0 and let's see what happens. Okay, finally the EIGRP adjacency is up. So show IP EIGRP neighbor. And then go on R1 as well. Show IP EIGRP neighbor. So notice that the TOS value did not affect the EIGRP neighbor adjacency. The routers were still able to form an EIGRP neighbor relationship regardless of the TOS values being configured differently, although iOS may have automatically changed it to 0 again, so let's verify that. Let's look at the final configurations. So let's copy this. Then on R1. So here you can see it is 0. Actually, I don't want to highlight that because then I lose the copied command. And the same is here as well, actually. So they both changed to 0, even though we configured them as different values. So let me go back here. This line right here, we configured it as 8. Anyway, after this very long explanation and mess, this is how you configure the metric weights in classic and named mode. Thank you for watching, and I'll see you next time.